Basics of Python, Lesson 2. Hello everyone. Today we're going to have the second class on Python Web, which is to introduce some basic knowledge of Python. It mainly includes the following 4 parts. First, we're going to introduce the main concepts inside the Python programming language. Then we'll introduce the data structures in the Python programming language, as well as control structures and derivatives. Finally, we will introduce how to read and write data in the Python programming language. So first, let's look at the basic concepts in the Python programming language. In the last lesson, we mentioned that Python is an interpreted programming language. So what is an interpreted programming language? As long as we understand the differences between an interpreted programming language and a compiled language, we will understand what is an interpreted programming language. Please find the differences in the picture on the right. Programming languages make it possible to describe human logic in source code, and eventually the source code will be translated into something that a computer recognizes so that it can be read and executed by a computer. For a compiled language, the translation goes through a procedure called compiling. This is after a programmer writes the source code. The compiler will translate the source code into a program that is in the format of a machine code. Then CPU will load the program into memory and execute it. On the other hand, for an interpreted programming language, there is no compiling. Once the programmer completes the source code, the interpreter can just read the source code and execute it to get the result. The interpreted programming language and the compiled programming language both have their advantages. Go back to Python. Python is an interpreted, interactive, object-oriented, dynamic, high-level programming language. We have talked about these characteristics in the last lesson, so we won't spend much time on them now. One of the areas when Python is used is data analysis and website development. Here you can find some examples of how different types of programming languages. The most popular compiled programming languages include C, C++, Go and Swift, and the interpreter languages are JavaScript, Python, Ruby, and PHP. But C# and Java are a little different. Strictly speaking, they are not a compiled programming language. So let's see. There are 2 programming modes in Python. One is interactive programming and the other is scripted programming. Let's look at what interactive programming is. Interactive programming means that we don't need to create a script file. The code is written and executed through Python's interactive tools. For example, the Python shell, IPython, and Jupyter, which we introduced in the last lesson, are all interactive programming tools. Here is an example. After we type the command python3, we will enter the shell interface of the Python interpreter. In this shell, we can type our Python code and press enter. And then, the result of the code will be returned immediately. This is the so-called interactive programming process. Interactive programming is mainly used for learning programming languages, but not for building Python web applications. Well, if we want to build Python web applications, we need to learn scripting style programming. Scripting means that we first create a Python script, and then write all the Python source code to the script file. This script file usually has .py as its extension, which is the default extension by convention. Then when we want to run this script file, and if we are on Linux, we just execute the command Python, then space, then the name of the script file, and press enter. Then this script will be executed. Then we look at Python's identifiers and reserved words. Of course, identifiers and reserved words exist in almost all programming languages, and they are mainly related to the naming convention for variables and reserved keywords. We will now only cover the case in Python. Let's look at what an identifier is. It's something that identifies a variable, constant, function, or block of code, etc., so that we can establish a correspondence between the name and what it specifically refers to. There are some naming conventions for Python identifiers. For example, an identifier can only be composed of letters, numbers, and underscores. Usually, we use these three to build a Python identifier, and then the requirements associated with the identifier. In addition to this, is that numbers are generally not used as the beginning of the identifier, which is a default rule. Then Python's identifiers are case sensitive. For example, I want to name a variable with AB, but we have to know when A and B are in uppercase and lowercase. They are different variables. Then if an identifier starts with an underscore, it usually has a special meaning. For example, a variable that starts with an underscore may be a private variable of a class, and a function name that starts with an underscore is usually a private function of a class. So what is a reserved word? A reserved word, also known as a keyword, is a keyword in a programming language that is reserved for use in its syntax. In the Python language, there are 31 keywords. I've listed these keywords in the chart here. We will cover some of these keywords in the future. Today, I'll start with a few of them as examples. First, for example, AND is used when two Boolean expressions need to be connected by an AND to determine the final Boolean value. The following one, break, for example, is used in the loop control structure to jump out of the loop control structure by breaking. Another example is the keyword class, which is used when defining a class. In the first line of the class definition, the keyword class is added before the class name, and we cannot use these reserved words to name identifiers. If we use them, it will create a conflict, because there are keywords that the Python programming language reserves for its use. Then we will look at how to divide blocks of code in Python programming. One of the major differences between Python and other programming languages is that many mainstream programming languages use curly braces to separate blocks of code, whereas Python uses space indentation to identify a block of code from another block of code. Let's look at the diagram on the right. If true : print true. For the if true branch, the following block of code has only one line. How do we know that a block like print true is a branch under if true? It is by adding some spaces as an indentation in front of it. Similarly, the else branch is followed by the next line of code, which is also taken as a different block of code by the introduction of multiple spaces in the indent. The number of spaces in an indent can be arbitrary, but for multiple lines of coding belonging to the same block, the number of spaces at the front of each line should be consistent. For example, in the diagram on the bottom right, there are two lines of code under the else statement at line 11. That's lines 12 and 13. So we see that lines 12 and 13 because they don't use the same number of spaces as indentation. This code will report an indentation mismatch error. Such an error in Python can easily confuse or even annoy new programmers, and it requires a lot of care. The program behavior is sometimes very different because of extra space or missing space, but such errors are often not easy to detect. Sometimes it is possible to have a particularly long line of code. It may be too long to be displayed as one line on the screen. Of course, it is not common, but it is possible. When it happens, we need to break the long line into multiple short lines and have something between every two lines to show the line continuation. What we are using here is the backslash. With backslashes, we can put a very long statement in several lines, which will be much easier for programmers to read. Let's have a look at the example at the bottom left corner. It is to get the sum of three variables. As you can see here, variable number 1 plus backslash, then continue from the next line, number 2 plus backslash. Again, continue from the third line, number 3, then that's the end of the statement. We can see here, by adding backslashes, we can divide one long statement into multiple lines, and each line is short enough to be easily read. But there is a special case when the statement has a long data structure which contains many elements and those elements are separated with commas. In this case, we don't need to add backslashes to break such a data structure into multiple lines, because it can just be divided by the commas, and we don't need to append a backslash at the end of each line. Then let's look at what quotation marks do in Python. In Python, there are three types of single quotes, double quotes, and triple quotes. All three are used to express the form of a string. We will talk about the types of variables later, and one of them is called the string type. When assigning a string to a variable, we wrap it in quotes, and what's inside the quotes is a string. Let's look at these example in the bottom right corner, which is 1 equals word. The word is wrapped in single quotes, which means that the value of the string word is assigned to the variable 1. Then of course we can also use double quotes to wrap a string, as shown in the second line. For string, single quotes and double quotes are the same. Choosing which one is up to you. Then in the third line, the variable is 3, and the string assigned to it is wrapped in a pair of triple quotes. Here it is different from single quotes and double quotes. The content between the pair of triple quotes can be crossing multiple lines. We don't need to use the backslash to show the line continuation. That is something special. Let's look at comments and blank lines in the Python language. We know that a good programming habit is to write rich comments. The syntax of comments is not quite the same inside different programming languages. In Python, we start with number sign, and everything inside the line after number sign is part of that comment. That is, when the Python interpreter gets to this line, it will ignore it on purpose. Because the line starts with number sign, the interpreter knows it's a comment line. On the other hand, when we are writing a big comment with multiple lines, we don't often write a number sign at the beginning of each line. Of course, you can still do that. To have number sign at the beginning of each line is not a problem, but there is something easier. We usually start a multiple line comment with 3 single quotes. Note that it is 3 single quotes. Then after the 3 single quotes, we can write a multi-line comment. How do we mark the end of the multi-line comment? That is, another 3 single quotes. So a pair of 3 single quotes wraps a multi-line comment. So these are the syntax of comments in Python, including single-line comments and multi-line comments. For example, in the screenshot at the bottom left corner, a number sign followed by "this is a string" forms a comment. Next, let's talk about blank lines. What is the main purpose of blank lines? It is to distinguish different code structures. For example, we define a function and then define the second one, and then the third one. Then between these functions, it is better to separate them by blank lines, so that the programmer can easily find that these are three different functions. Similarly, when we define variables, we can also separate the variables with blank lines. In this way, the structure of the code will look clearer, unlike indentation, which is a requirement of Python syntax. Blank lines are not part of Python syntax. You can choose to write blank lines or choose not to write them. It's just a matter of the coding habits of programmers. So this is the typical use of blank lines in Python. Then we will look at a very important function in Python called print. The main purpose of this function is to print out the value of a variable when we want to check it. Or to check it, the variable is of the correct type. And the function print prints to the standard output. That is, when the print function is executed, the content will be output to the computer screen, which is also known as the standard output. Between Python 2 and Python 3, the print function has some differences. Specifically, in Python 2, when we want to print a variable or print a line of comments, we can use print, add a space, and then add the variable. Alternatively, in Python 2, you can also use the function form of print, which is print plus parentheses, and then put the variable inside the parentheses. In Python 3, the keyword print was removed in order to keep functions clean and consistent. So only the print function was retained and supported. Let's look at the example on the right. In Python 2, the first line of print I like eating apple is fine, and then we put I like eating apple in parentheses after print, which is also fine. Both of these forms are supported in Python 2. There is a small detail here. By default, after printing the value of a variable, print will automatically wrap the line. And the next time you call print, it will print on a new line. However, if you don't want to have a line break, but to have both prints on the same line, you can add a comma after the first both printed on the same line. You can see the example in the screenshot at the lower right corner, which shows such a difference. When print x is executed, A is printed with a new line. When it is written as print x with a comma, A is printed with a space and no new line. And then print y on the same line, which is equal to B. And then there are some more details. When we want to print two variables together, we can write it directly like this. That is, print xy. In this case, the result it produces is x is how old are you? And then the comma, which will be expressed as one space, or output as one space. And then y is 18, so its output is like this. How old are you? Space, question mark, space, 18. And these are printed in the same line. Then the print function can not only print the value of variables, but it can also print the result of a calculation. For example, if x is equal to 10 and y is equal to 100, when we write print x plus y, it first calculates the result of adding the values of the two variables x and y. So its output should be x plus y, because it is a string, and then the comma. It will be converted to one space. And then the result of x plus y is 110. So eventually this is the output. Then we will look at variable constants and types in Python. What are variables? Variables are used to store values that may change during the program. variables store these values in memory, which means that variables open up a space in memory when they are created. Variables have data types, and the Python interpreter allocates memory based on the variable's data type and determines which data can be stored in the allocated memory. Common data types such as integers, floating point numbers, characters, strings, and so on will be covered in detail later. Then we can use the assignment operator, the equal sign, to connect the variable name to the value of the variable we want to assign. In Python, we don't need to specify the type of a variable. This is done autonomously by the interpreter, as opposed to Java or C++, where the programmer needs to explicitly assign a specific data type to a variable. Variables can be repeatedly assigned, that is, their values can change, and the change can be not only the value but also of the data type. That is, you can use different types of values to assign to the same variable. This is why Python is a dynamic language. For example, the 1 equals work in the bottom left corner is an assignment statement. We assign the word string to the variable 1. Another example is the number equals to 1000. When we assign an integer like 1000 to the variable number, of course, it is possible to use complex data structures, as in this example, when we assign a list to the variable list. The above is the assignment of variables and variables in Python. Then, Python also supports assigning values to multiple variables at the same time. For example, if we have a value of 10 and I want to assign it to two variables at the same time, we write it like this: x equals to y equals to 10. Alternatively, we can assign different values to multiple variables. For example, if we assign 3 variables to 3 different values, we should write the variable names separated by commas, and the values to be assigned to each of them in the same order, separated by commas accordingly. Like in this example, the 3 variable names A, B, and C are placed together, separated by a comma, followed by the assignment operator and then the 3 values. In this case, the first value, the string A, is assigned to variable A. The second value, the string B, is assigned to variable B. And the third value, the integer 1000, the integer 100, is assigned to variable C. So Python supports such a multiple variables assignment. After variables, let's look at constants. What are constants? A constant is a value that will never be modified in the program. That's why it is called a constant. It can give you some examples of constants. For example, P is a typical constant that should not change no matter what happens in your program logic. Another example is the natural number E, which is also a typical constant. Those constants won't be changed because of the logic in a program. In Python, there are no specific keywords or reserved words to define constants. In practice, to distinguish constants from variables, we usually use all capital letters for the name of the constants. Now we look at the types of data below. Usually, programming languages have multiple data types. In Python, there are 5 main standard data types, including numbers, strings, lists, tuples, and dictionaries. Why do we need these data types? We know that different values have different types. For example, age is usually represented as an integer, and the name is usually represented as a string. So in the program, when dealing with such different values, we need to use different data types. Of course, in Python, this type of designation is implicit. That is, the programmer does not need to specify it explicitly. It is well understood that different data types take up different amounts of space in memory. So the Python interpreter needs the data type information to determine how much memory to allocate for each variable. Let's first look at the case of numeric types. Numeric types include different types as well. For example, the int type, which is a signed integer, is a type that represents an integer and it can be either a positive or negative number. Also, the numeric type includes the long type, which is a long integer. It expresses a large range of such numbers that int, but it is also a signed integer. Also, there are floating point types, which are what we usually call decimals. Besides, there are complex numbers and so on. Next, let's look at floating point numbers. A floating point number is a number having decimals, and it is usually used when high precise calculations are required. Why it is called a floating point number? Because floating point numbers contain a fractional part, which is used when precision is required in a calculation. The storage of a floating point number is a computer contains two parts. One part stores the value and the other part stores the scaling factor, which is equivalent to indicating the position of the decimal point. So that's why it is called a floating point number. For example, 3.14 and 6.66 are floating point numbers. If we want to represent very large or very small floating point numbers, we usually use a scientific notation. In high school courses, you should have learned about a scientific notation. And Python supports the scientific notation specification, which use e to represent a power of 10. For example, 1.2 E5, which means that 12,000 is 1.2 times 5 times 10, which is scientific notation. Then let's look at the string type. A string is made of a number of characters. These characters can be a number, a letter, or an underscore. For example, if we assign apple to the variable s, the string is composed of 5 characters, A, P, P, L, E. Then the string can also contain a special class of characters called escape characters, which are characters with special meanings, such as new lines and tabs. Examples of escape characters include, for example, /n to indicate a line break, /2 indicate a tab. Above you see what is a string. Let's look at the indexing of strings. In Python, there are 2 ways to index characters in a string. One is from left to right, so the index starts at 0 and points to the first character in the string. And the maximum value of the index is the length of the string minus 1. Another way is from right to left, where the index starts at -1 and points to the last character in the string. Then the second character from right to left is -2, and so on. If we want to get a substring, we can enclose it in square brackets and specify the index position from the beginning to the end of the substring in the string. So let's look at an example. For example, if we assign hello world to the variable str, then when we get a substring, the index is from 0 to 5, and the value of the substring is hello. In this example, the index value of the end is 5, but the character corresponding to index value 5 is not included. That is, the space between hello and world is not included. So if you want to index from right to left, in our example, the square brackets are indexed from -3 to -1, which means that the characters taken out are L and D. Of course, we don't usually use this right-to-left indexing method. The Boolean type is also an important data type in programming languages, and it has only 2 values, true and false, which are usually obtained by comparison or conditional operations. For more information about Boolean operations, see the table at the bottom left. There are several operations on Boolean values, but we will only look at AND here. In this example, the AND operator is used to do a logical AND operation on the Boolean values on both sides of AND. So we can see that true and true gets true. True and false gets false. So in this statement, print true and false, we get false. Then there is a special value in Python called none, which is the null value. It represents a value that doesn't exist. For example, if we assign none to the variable x, and then we print the data type of this variable x, we will see that the output of the data type none-type, which is a special type. Then we will look at operators. There are 5 major categories of operators in Python, including arithmetic operators, comparison operators, assignment operators, logical operators, and bitwise operators. So let's first look at arithmetic operations, which are binary operations on 2 numeric objects. The arithmetic operators in Python include the following operators. The plus operator means to add 2 values. For example, if we assign a value of 10 to variable a and a values of 3 to variable b, the return variable of a plus b will be equal to 13. Then there is a minus operator, which means to subtract 2 values. As in the previous example, a minus b will be equal to 7. Similarly, there are multiplication, division, exponentiation, and modulo operations. The tools express the square or exponential operation. Continuing from the previous example, a equals to 10 and b equals 3, so the value obtained by the arithmetic expression a multiple b will be 3 times 10 or 1000. The last percent expresses the modulo operation. When a equals to 10 and b equals 3, the modulus of a%b is 1. The above is the introduction of arithmetic operators. Next, let's look at the comparison operator. The comparison operator is used to compare 2 Python numeric objects. The comparison operator returns a Boolean value, which means it can only return true or false. And the table at the bottom left lists all the comparison operators in Python, from top to bottom. The double equal sign, which determines whether 2 variables are equal, an exclamation equal sign, which expresses whether 2 variables are not equal, followed by greater than, less than, greater than, or equal to, and less than or equal to. To continue with the previous example, if variable a equals 10 and a variable b equals 3, then a comparison operation like a equals b should return false because 10 cannot equal 3. Similarly, a exclamation equal b would return true. These are the Python comparison operators. So let's look at Python's assignment operators. The main purpose of the assignment operator is to assign a value to the variable on the left. At the same time, we can also do some operations during the assignment process. In this list, we can take a look at a few of the assignment operators that Python provides. The first is the equal sign, which is the simplest of the assignment operations. For example, c equals a plus b. Since the value of a is 10 and the value of b is 3, then c equals a plus b, which means that the value of c equals 13. For the operator plus assignment, it means that the left and right values are added together and then assigned to the left value. In this case, c equals 0 and a equals 10, so c plus a is still 10. And then the result of this addition is assigned to the variable c. Similarly, the next operator is the subtraction assignment operator, which means that we subtract first and then assign the result of this subtraction to the variable. The next ones are multiply and then assign, and divide and then assign, and modulo and then assign. These are the assignment operations in Python. Then up to this point, we have roughly explained the basic syntax of Python. Next, let's look at what data structures are available in the Python language. In programming languages, data structures are mainly used to contain elements of values. In Python, there are four main types of data structures: lists, tuples, dictionaries, and sets. Let's go through these data structures one by one. First, lists. A list is an ordered sequence structure. The elements in the sequence can be of different data types. What are the main scenarios for its use? It is suitable for scenarios where data elements need to be modified and can be traversed so that the same operation is performed on each element. For example, if we have a list of students' grades, how do we find the highest achieving students in such a list? In this case, we may need to iterate through each element of the list of student grades, which is a suitable scenario for applying lists. Lists in Python provide many different operations. For example, indexing, that is, accessing an element of a list based on its index value. Then there are slicing and mathematical operations on the elements of the list. In terms of the definition format, the elements of the list are separated by commas, and then all elements are included in the periphery by using square brackets. For example, in the bottom right corner, there are two examples. The first example defines a list 1 with 6 elements, each with a value of a numeric type. These 6 elements are wrapped in square brackets. Then a list is formed. Then list 2 is a list with 3 elements, each of which is of the string type. However, as we mentioned earlier, the elements in the list can have different data types. Then let's look at the operation for a list. For example, we want to index a specific element from the list. To continue with the previous example, the list 1 contains 6 elements, 1, 2, 3, 4, 5, and 6. We want to get the value of the element at position 0. So we use list 1, which is the name of the list, and then the square brackets, and enter the index value 0 inside the square brackets. This expression represents the value of the 0th element in the list, which in this case is 1. If we want to get the value of the sublist with index position between 0 and 2, we use the same indexing method as getting a substring from a string, which in our example is list 2, and then take the square brackets and write the index value of the beginning position and the index value of the end position in the square brackets, which in this example is 0 and 2. What does the sublist we get this way look like? In this example, that is A and B, starting from the starting index value. The value of the 0th element is the character A, and the value of the first element is B. The next index value is 2, and the corresponding element value is CDE. But 2 as the index value of the end position is not included in the scope of the sublist. So we get a sublist composed of 2 elements of A and B. What if we want to add an element to a list? We use the append method. What this append method does is add a specified element to the end of the list. But we always keep in mind that there is an order to the elements in the list. Then, for example, for the list 1, we add an element 100 at the end of it. So we use the list1.append method and pass 100 as the parameter. Let's look at the list after the append operation. Its value becomes 1, 2, 3, 4, 5, 6, 100. That is, we add an element 100 after the previous list element. Then if we want to remove an element from the list, we use the remove method, which removes the element specified in the list. Note that the parameter passed to the remove method is the value to be removed, not the index in the list. For example, if we want to remove the elements of value 3 from list 1, we call the remove method with list 1 and pass in 3 dot if list 1 contains several 3. That is, if it contains more than one of the elements having the same value, all these elements will be removed at the same time. And then the list 1 after removal will contain only 1, 2, 4, 5, 6. The element of value 3 has been removed. Also, sometimes we may not know the value of the element to be removed, but only the index of the element. Then we can call the pop method. Pop does not take a specific value, but an index. For example, if in the statement list1.pop3, the parameter of pop is 3, it means that the element with index 3 is removed. So we see that the final result is 1, 2, 3, 5, 6. 4 is removed because the element of the index 3 is 4. Then let's see what if I don't want to add an element at the end of the list, but instead to add an element at the specified index position. Let's use the method insert. For example, we want to insert the value 100 at the third index position of the list 1. Then we call list1.insert 3, 100. In this method, the first parameter 3 is to indicate the index position is 3, and the second parameter 100 means the value to be inserted. Then after executing this line of code, the elements of list 1 become 1, 2, 3, 100, 4, 5, 6. Then what if I want to know how many elements are there in a list? Python provides a built-in function called len. Let's look at this example where list 1 was 1, 2, 3, 4, 5, 6. After we insert element 100 in the third position, we can see the number of elements changes in list 1. Originally, it has 6 elements, but after inserting a new element, the number of its elements is 7. Then we will look at the tuples. So what's a tuple? It is also a major Python data type or data structure. It's similar to a list because the elements can be of different types. But the difference is that the main use scenario of a tuple is to make these statements unmodifiable and to ensure the safety of the data. For example, when we define a function, multiple return values can be saved using a tuple. In the form of the definition, the tuple is in parentheses, while the list is in square brackets. Since the elements of a tuple are immutable, that is, once initialized, we cannot modify a tuple. If we try to modify it, Python will report an error. So a tuple does not have methods like append, insert, del, remove, etc. that change the elements as a list does. Then if we want to get an element from a tuple, the operation is very similar to that of a list. That is, we can get the value of the tuple element at the index position by using a specific index value and including the index value in square brackets. Also, we can get a subtuple by specifying the start and end index. in these 2 points, the example here is very similar to the one in the list. As mentioned before, we see that a tuple is a data structure that does not allow to modify its elements. Therefore, if we want to modify a tuple, we have to create a new tuple. For example, we can join 2 tuples, i.e. tuple 1 and tuple 2 with a plus sign, to create a new tuple. When we print this new tuple, the elements inside it are 1, 2, 3, 4, 5, 6, and then A, B, C, D, E. Then we look at the dictionary, which is also called a hash map or an associative array. Its main structural form is the key-value form. One of the main scenarios of dictionaries is to express the association of data through key-value pairs. For example, we use a string like age as a key, and the corresponding value is 18. And the dictionary is a variable-sized collection of key-value pairs, where the keys and values are Python objects. The main advantage of a dictionary is that it can be used for fast or high-speed lookups. By using an index value such as a key, you can quickly find the value corresponding to it. Dictionaries are created by using curly brackets to contain key-value pairs and using colons to separate keys and values to form such a key-value pair. Then the dictionary, its data elements are unordered, unlike list, where the elements inside the list are ordered. The elements in the dictionary are not arranged in the initialized order. Different keys can have the same value, but the same key must have the same value. That is, no one key corresponds to more than one value, which is a characteristic of dictionaries. Then we look at the index of the dictionary. That is, when we want to get a value in the dictionary, we can go through the key to get the specific value corresponding to this key. For example, in the bottom left corner of this example, we have created a dictionary. It is dict1. What is it? It contains 3 key value pairs. The first key value pair, its key is the character A, which corresponds to a value of 1. Then the second element, its key is B, which corresponds to a value of 2. The third element's key is C, which corresponds to a value of 3. If we want to get the value corresponding to key A, we can use dict1 plus the square brackets and enter the key into the square brackets, and then we will get the value printed. Another way to get the value corresponding to the index position of the dictionary is to use Python's built-in get method, which takes the key as an argument and returns the value corresponding to the key in the dictionary after the key is passed in. If the key doesn't exist in the dictionary, it will return none, because it can't find the key. And of course, it can't find the value corresponding to the key in the dictionary. Notice here, please. If the key does not exist in the dictionary, the get function will return none and no error will be reported. But if you get the value corresponding to the dictionary key using indexing, that is, using square brackets, if the key does not exist in the dictionary, there will be an error for the program. Of course, there are several main types of program errors, but we'll explain these in more detail in the subsequent chapters. What we just talked about is a runtime error. Then let's finally look at the set. What is a set? It is an unordered element collection, which means that the elements in the set are not ordered, and it is a collection of keys and there are no values. Also, duplicate keys are not allowed in a set. That is, duplicate elements are not allowed to exist in a set. So a typical usage scenario for a set is to remove duplicate elements. For example, if I merge all the courses taken by each student, I can get a set of all the courses in that grade at the school, which is a specific scenario of using set. Sets can also perform some mathematical operations, such as taking the merge, intersection, and difference sets. There are two main ways to create a set, either by using the set function or by using curly brackets. Let's look at an example on the right. We have created four sets. The first two of which are set 1 and set 2, which are created by using curly brackets. Then set 3 and set 4 are created by set function. Then there are four main operations between the sets. One is to merge, that is, all the elements of the two sets are combined, and all the duplicate elements are removed to obtain a final set. There is also the intersection, which is to take the same elements of two sets. The other operations include taking the difference set and taking the symmetric difference set. Then we'll look at two examples. The first is to merge two sets. For example, there are two sets, set 1 and set 2. Their values are 1, 2, 3, 4 and 3, 4, 5, 6. Then we go through set 1 and set 2 to merge them and remove the duplicated elements. We will get 1, 2, 3, 4, 5, 6. Next, we have an example of the intersection set. In this example, set 1 and set 2 are still the same as in the previous example. Then we take set 1 and set 2 to do the intersection. We can see the same elements are 3 and 4. Therefore, after taking the intersection, the elements inside the result set are 3 and 4. Above, we introduced the main data structures of Python. The next content is the control structures and the derivatives of Python. Let's start by introducing control structures in Python. In programming languages, a control structure is a judgment condition that defines the direction of data flow in a program. The judgment conditions here are mainly generated by Boolean expressions, so that the cases that satisfy or do not satisfy the judgment conditions can be processed. There are three main types of control structures in Python. First, conditional control structures. Second, control structures of for loops. And third, there are control structures of while loops. Before we introduce these three types of control structures, we first need to understand what a Boolean expression is. A Boolean expression is a statement of a piece of code, which is characterized by the fact that it only returns two values, true or false, in the end. The simplest example of a Boolean expression is the equation, which is the connection between two variables by equals and equals to determine whether two variables are equal. For example, 2 equals 4 is a typical Boolean expression that returns false. Then we first look at the first control structure, which is the conditional statement. Conditional statements all contain a Boolean expression inside, which returns whether the condition is satisfied or not, and then determines the execution path of the program based on whether it is satisfied or not. The top right corner shows the typical structure of a conditional statement. The if is followed by a judgment condition, or a Boolean expression. When this condition is satisfied, it executes the code block below the if. In the case that this condition is not satisfied, it executes the block under else. This is the program logic of a classic conditional statement. In Python, there are three types of conditional statements: an if statement, an if-else statement, and an if-else statement. Let's introduce each of these three types of conditional statements with an example. The first example is the if conditional statement. Well, we assign a value of 18 to the variable age. And the Boolean expression here is age is greater than or equal to 18. We know that since age is equal to 18, the Boolean expression 18 is greater than or equal to 18 returns true, which means that the condition is satisfied, and then it will execute a block of code like the one below the if, which is print, you are an adult. And so the output is like this. Then we look at an example of the if-else conditional statement. The variable age is assigned to be 12, and the if condition is still age greater than or equal to 18. We know that 12 greater than or equal to 18 returns false, which means that such a condition is not satisfied. The else block will be executed and print, you are a minor. Next, let's look at an example of an if-elif-else structure. The variable age is assigned to be 60. Each of the subsequent conditions will be checked one by one. First, age is less than 18 is not satisfied. Then age is greater than or equal to 18, and age is less than 60 is not satisfied. So it will execute the else block, which means to print, you are an old man. Next, we introduce the second major type of control structure, that of the for loop. Programs are executed sequentially in general, but programming languages provide a variety of control structures that allow for more complex execution paths. Loop statements allow us to execute a statement or group of statements multiple times. For loop statements can access each element in turn in a sequential manner and process it in turn. The basic form is as shown in the top right corner. For element in data structure, which is to perform a traversal of each element in the data structure, and then perform the same operation for each iteration, i.e., to execute the following block of code. So this block of code will be executed repeatedly. So when does the loop end? That is, when the data structure, say a list or a tuple, has been traversed, the for loop block is finished. Then we'll look at an example. We have a list of ages called age list. Now we want to make each element in the list twice as big as it is. We do this through a for loop, which is for age in age list. For each element in age list, we perform a multiply by 2 and add the result to a new list. Finally, printing this new list variable will give us 22, 44, 66, 88, and 110. Let's take a look at the while loop control structure. While statement in Python is used to loop through a program, i.e., to execute a certain segment of the program under a certain condition to handle the same task that needs to be handled repeatedly. While loop differs from for loop in that its stop condition is set by the programmer, and the loop ends when the judgment condition is not satisfied. Its loop condition can be any expression. Note that any non-zero, non-empty value is always true. That is always satisfied. The typical program structure of the while loop control structure is while, followed by a judgment condition that is written by the programmer. If this judgment condition is satisfied, the program code inside the while block is executed. Then let's take an example of a while loop. This example says that a variable x is initially assigned a value of 1 if the condition that the value x is less than 10 is met. We first print the value of the variable and add 3 to the variable. After repeat adding 3, the value of x naturally becomes larger and larger until the condition that x is less than 10 is no longer met, and the while loop terminates. So with such code logic, we can see that the output statement, i.e. print x, is executed 3 times. For the first iteration, x equals to 1. The second one, x plus 3 equals 4. Print 4. The third one is 4 plus 3 equals 7. Then the fourth one, 7 plus 3 equals 10. This time the condition 10 is less than 10 is no longer satisfied. Therefore, the while loop terminated in the fourth iteration. After the 3 basic types of control structures in Python, next we are going to introduce derivatives. Python is a concise computer language that is close to natural human language, provides a way to write loop control structures conveniently. That's the derivative. Here we are introducing the list of derivatives, but the similar syntax is also applicable to tuple, dictionary, and set. All the loop control structures we introduced have to be multi-line. Below we introduce methods to construct the lists using for loops inside the lists or dictionaries, which can make the source code more readable, convenient, and concise. For example, now we have a list with 5 integer values, and we want each element in this list to be multiplied by 2. Let's see how to implement such a function in a derivative way. The age list in this example is the same as in the previous example. The derivative is written in such way. First, the derivative will eventually generate a new list, and this new list will be assigned to the variable double age list. By iterating through each element inside the square brackets, that is, for age in age list, and for each element returning the value multiplied by 2, and collecting all the returned values, a new list is formed. This is a standard list derivation style, which implements the traversal and manipulation of all the list elements in one line. Finally, we print out the double age list, and we will see that its elements are 22, 44, 66, 88, and 110. This example completes the simple introduction to list derivative. Next, we are going to introduce how we read and write data in Python programming. First of all, in the computer field, there are usually 3 types of data reading and writing operations. First is the standard input and output, that is, through the keyboard input or screen output. The second is file reading and writing operations. And the third is the database reading and writing operations. In programming languages, data manipulation is an extremely common operation. The process generally includes data loading, data processing, and data writing. Among them, data loading and data writing refer to the data reading and writing operations. We can briefly introduce the standard output we mentioned just now. It refers to the running program printing the data in memory to the screen, which means output the standard output device. Similarly, standard input means that the user enters data into the program running in memory through the keyboard, which means that the data is entered through the standard input device. We often print some information to the standard output in a program for debugging purposes, etc. Next, let's look at what's available in Python if we want to read data from standard input. Python provides 2 built-in functions to read a line of text from standard input. The default standard input, as we talked about earlier, is the keyboard. So what are these 2 functions? One is raw input, and the other is input. Let's look at the raw input function first. Raw input reads a line of data from the standard input and returns a string. When returning a string, raw input removes the new line character at the end of it. After the user types a line of text from the keyboard, he or she hits the Enter key. When Python reads the line from the user's input via the raw input function, it removes the new line at the end of the line. Then let's look at input. Input is similar to the raw input function, but input can take a Python expression as input and return the result of the operation. So let's look at two simple examples. First, in the upper right corner is an example of the raw input function. Raw input takes one argument, which is please input a string in the example. And this argument is the prompt message that is printed on the screen. After seeing the prompt, the user can enter a string, and raw input returns this string, which we assign to the variable string. For example, if the prompt shows please input a string and the user types hello world and enters, the Python program gets this input and prints it as we just said, i.e. the following line in the example, your input string hello world. Next, below the raw input example, there is an example of the input function. Similarly, there is also a prompt, please input a string, but the string that the user enters is not a normal string type, but an expression. For example, the list derivation we just talked about. The list derivation in this example operates by adding 1 to each element of a list, 1, 2, 3, 4, 5. When we return this program, we see that the result is printed as a list 2, 3, 4, 5, 6. This means that the input function considers the user's input to be a Python statement and outputs the result of it, rather than treating it as a normal string. After we talked about the standard input and output operations, let's look at how to read and write data from a file. First, let's look at reading data from a file. To read data from a file, we need to use a built-in Python function called open. Open means to open a file. The first parameter of open is the path to the file, and the second parameter is mode equals R. This mode means whether the file is open to perform a read or write operation, or both read and write operations. In this example, mode is equal to R. The parameter R expresses that we want to perform a read operation. In this example, open opens the file and returns a file handle, which we assign to the variable phi. Therefore, the variable phi only has read access to the file. It does not have write access to the file. If you want to open it in read-write mode, then mode should be equal to RW. Here we see that the file contains 5 lines of hello Python. So we open the file and assign the file object to the variable phi. In the following, we will see how it reads the contents of the file. To read the contents of the file, we use the read function, which will return all the contents of the file, and then print all the contents of the file in this example. The result of the execution is shown in the screenshot on the top right corner. Then, after each time we finish using the file, we have to close it. That is, to call the close method of the file object. Otherwise, the file will always be occupied by Python, and other processes will not be able to perform read and write operations on the file. So it is important to keep in mind to perform a close operation for an open file. But there is another convenient way of writing, because after a programmer opens a file and reads its contents, there is a good chance that he or she will forget to close the file. If this is the case, it will make the file unavailable to other processes. To prevent programmers from forgetting to write this close operation, an easy way to write it is with open as shown in the screenshot at the bottom right. The open function in with open is called in the same way as it is called in general. as phi is the equivalent of assigning the file handle returned by the open function to the phi object. Then we read the contents of the file through phi, assign it to the variable content, and then print the content. The result of these three lines is the same as the one in the previous screenshot. But the advantage is that the programmer does not have to explicitly call the file object's close method. Then we look at how to write the data in the program's memory to a file. And one of the main methods used at this point is the write method. Again, we first need to open the file to be written, also using the open function. The only thing to note is that it is now open in W mode, which is write mode. After opening, the file handle returned by open is assigned to the variable phi, and then the write method of the phi object is called to write the file. In this example, the argument passed to write is hello Python, which is the content to be written. Then, after writing the file, don't forget to close it, i.e. call phi.close. After executing this code, we open the write file text file with another tool to verify its contents. We can see that the file was empty, but now a line of hello Python has been written. With these examples, we can see how to read data from a file and how to write data from memory to a file. Finally, let's summarize the main content of this lesson. We introduced the four main parts. The first is some basic concepts involved in Python, then the data structure of Python, and the control structure of the Python language and the way to write derivatives. And finally, we talked about reading and writing data. In the first section, we introduced the basic concepts of Python, such as identifiers and the related rules, how to make comments, and the use of the print function. We mentioned that you can use print to print some information when doing debugging. And then we introduced the basic concepts of variables, constants, assignment of variables, and data types in the Python programming language. After that, we introduced the data operations in Python, including arithmetic operations, assignment operations, and so on. In the second part, we introduced the four types of data structures: list, tuple, dictionary, and set. And for each type, how it is created, how to get an element in the data structure, and how to add or delete, etc. In the third part, we talked about control structures and derivations. One of the important concepts in control structures is Boolean expressions and if-else and the related conditional statements, as well as for and while loops. Finally, we introduced the list derivation. Then, in the data reading and writing section, we introduced standard input and output operations. That is, how to get user input from the keyboard, how to print program data on the screen, and how to read and write files. Based on what was explained in this lesson, let's move on to the knowledge of actual coding. Our code is executed in an IPython environment. First, we enter IPython command in the Linux shell, and when we return, we enter a running interface for Python-like IPython. IPython is an interactive Python execution environment. So we can see that now we are using Python version 3.6, also known as Python 3 series. In this lesson, we explained identifiers, notes, print functions, etc. Now let's do the demonstration one by one. First, we define a variable, then assign a value to it, and print through the print function. Let's set an age variable, which has a value of 18. And then we print this age using the print function, and we'll get a value like 18 printed. We mentioned that Python is a weak data type language, and when we declare a variable, we don't specify its type. For example, now we declare a name, which is actually a string type, like Tom. If we print it out, So what's its value? It's Tom, but the values of name and age are different. Now let's take a look at this one. What's a data type? We use the type function. We'll print it out. We see that it's of type int. And then we will look at the data type of name. So it's a string, and we've talked about Python, where the string type is mainly string. Let's talk about the operators. For example, Tom, current age is 18, and we want to increase his age by 10, equals age plus 10. So what is the value of age? Let's see. Then it's 28. In IPython, of course, we can also print a variable without using print. If we enter this variable directly, it will output it as 28. This is addition. Let's think again. If it's multiplication, what's the value of C if we say A equals 10, B equals 100, C equals A asterisk B? It's 1000. If C equals 8 divided by B, what's the value of C? It's 0.1. If C equals B divided by A, what's the value of C? That's 10. By the way, Python has a division by zero error. Let's see, let B equals 0, then C equals A divided by B. It returns a division by zero error. For this Python string type, let's talk about indexing strings, such as defining a string. Stir underscore A equals hello Python. Stir underscore A, its value is hello Python. So if we want to get a word like hello, how many ways do we have? Strings are indexed that allows us to slice an original string. Then it is important to note that the index of our strings starts from 0. So how many of us are from 0? Yes, 5. We can count that H is the 10th character, E is the character with index 1, and L is index 2. Then the L index is 3 and the O index is 4. Why should we take 0 to 5? Because only the index on the left will be retrieved, but on the right it will not. The number 5 won't be retrieved. It actually takes the character numbers of 0 to 4 and 5 indexes. As we see, we'll take out the word hello. Of course, there is another way we can do that. Let's briefly introduce a list, which means that we can slice strings into specific characters through some of the string's operation functions, such as stir underscore list, which returns a list. Stir underscore A uses this string object to call the split function. This function we slice is to use a space as a slice. We get this stir underscore list. We can see that its values are hello and Python, 2 elements. Then if we want a hello in this stir, we can access its first element. And we get the word hello. Later, of course, we will explain in detail some of the data structures of this Python. Let's go on to look at the Boolean type of stir, which is true and false, and the corresponding Boolean operation. For example, let's see, I let A equals true. Note that true is a keyword belonging to Python. And B equals false. Let's see how two Boolean values do a Boolean operation. Like what should A and B be? It should be false. That is, A and B, one of these two variables is true, the other is false. And its value does an operation with it. So it gets the result false, right? What about doing an OR operation? Is A or B? Then get true. And OR, which are the keywords of Python's Boolean operation. And of course, we can also use this symbol. This is also the AND symbol, get false. Then this represents the OR operation and get true. This gives us an overview of some Python's basic data types, as well as the operations between them. Then look at Python's data structure. This list, tuples, dictionaries, and connections are included. Let's start by defining a list of Pythons called A underscore list equals brackets. And we can define it this way. To specify some values between the two brackets, we now have 1, 2, 3 as int types. We visited 1, 2, 3 of this list. If we want to add an element to the current list, we can use append function. For example, we add a 4. Now let's look again. The value inside this list is 1, 2, 3, 4. If we want to delete an element, you can use the remove method. For example, we remove 2 and find that 1, 3, 4, 2 has been removed from this list. Let's look at how tuples are defined. For example, if I want to define a tuple is a underscore tuple. There are actually two ways. One way is this. We can wrap the values inside the element in parentheses. 1, 2, 3, and then we can look at this a underscore tuple. Its value is 1, 2, 3. And we can define it this way as a function. But we need to be aware that it can only pass in one parameter. And if it passes in two parameters, it will fail. That's how it works. Let's take a look at a underscore tuple's value is 1, 2. We should also be able to pass this in by passing in a list. But we find that a underscore tuple has the same values where we can only pass in one parameter, either a tuple or a list. But we also said that a tuple is an unmodified object. That is, when a tuple definition is complete, you cannot add an element to it. For example, a underscore tuple dot add 3. If we want to add a 3, we will get an error at this time, because it does not have add function, no append as well. This means tuple is an object that cannot be modified, and you cannot add or delete elements to it. Then let's look at the dictionary, which is actually a key value structure. For example, let's just define a dictionary. And dictionary definition is in this way, wrapped in curly brackets. What about its elements? Include a key and a value. For example, if the key is age, then its value is 18, separated by colon. Then its second element key is name, and then its value is tome. Let's take a look at this a underscore dict. Its value is a key value structure consisting of two elements. Each one has a key and a value. So if we want to access this dict element, we access it through its key. For example, if we want to access the value of its age, it will return 18. In the same way, we access it through the name key and get tome. This is dict. Let's move to the control structure. It's if-else structure. For example, if age is less than 10, and then we print age. If we print, then we print this string. Which means it's an adult grown man. Let's rewrite the previous code. First, define an age equals 18. And then we write a judgment about the structure of if-else. So what is it? If age is smaller than 18, we will print it out. The case of else is that age is greater than or equal to 18. Then we print this is a grown man. This is an adult. Now this if-else structure has been written. If we enter, it may ask us to enter something. But if we enter again, this code will be executed. Since age equals 18 and it will enter the else branch, it will print this is a grown man. That is all about if-else structure. Let's get into loop structure. The for loop. Let's look at the while loop first. Assume I equals 10, a variable declared. Then we will make a judgment by the value of I. If I is greater than or equal to 0, we'll ask it to print i's value and -1 by 1. There are several kinds of statements, and the most concise way is I equals I minus 1, which gives I a new value. Of course, we can also write I minus equals 1, which is an abbreviation of I equals I minus 1. Let's end this while cycle, and we can see that it prints from 10 to 0, right? Because each time it prints, its value will be reduced by 1. When its value is less than 0, it will not continue, because it does not satisfy the cycle condition. Let's take a look at the for loop. For I in range, the range is a basic function of Python. It expresses the value from an initial value to an end value. This is the meaning of the first and second parameters. The meaning of the third parameter is the step. For example, if our step is 2, then at this time, let's print out the I. And we also see that it printed 0, 2, 4, 6, 8. 0 is the start value, and the value increased by 2 for each cycle until 8. Why isn't the value 10 printed? Because the value 10 is not fetched. It can only fetch 0 to 9 and takes a step as 2. Here we have given you a general description of the loop structure. Okay, this is the end of the code demonstration section of this lesson. Thank you.